It's because due to network, our infrastructure of network is very bad here in our country. But I'll just try to show you just as the network keeps on breaking down. So I'll show you anything I can. So this 12V battery charger was built using only 3 components on a plastic board. You can see this plastic board. I took it from this plastic container, not a breadboard. And you believe it or not, this plastic works. Let me show you how I did it here. Comment down below where you're watching from before we dive in, and smash the like button if you like how I take it. And don't forget to subscribe for more crazy videos like this. So this charger I built is simple, raw and functional using scrap parts I salvaged from electronics. Let's look at the back and front. I'll show you more other parts. Let me show you other parts which I used. Because this is not complete, because it can be connected. It's not going direct on the socket for 250 volts. We are going to use this transformer. That's another third part I was telling you about. This is the first, second, and third is this one. These only components can give you 13 plus volts here. And since I told you that this thing I built without in a hurry for a sample, just a sample. So these are how all items look like. This is for the main adapter, power adapter. Can you guess the voltage this transformer outputs before rectification? This transformer. Can you guess it? So instead of this bridge rectifier, you see this bridge rectifier. You can replace it by diodes. But I just wanted it to be simple without too much parts. Sorry, I'm just trying to make our network stable there. I'm just trying to make our network stable. So I'll be doing all these things like until the end of this video. I apologize. So here, the gadgets I used to build this thing is this multimeter. Yes, this is a smart multimeter. It auto adjusts this multimeter, but it's just a simple one thing to using it. Yeah, in my gun here, my soldering gun, and what test station that I don't use it. Yes, but it's available. But I use a simple gun like this. Cheap one too. So this project is just simple, but it's the foundation of my future DIY charger series. You'll see more charger series coming. This is the final. In the next, I'll be adding a potentiometer to control charging current and 5 MC DC fuse here. I'll add 5 MC DC fuse and a diode to prevent backfeed when this charger is off, and a voltmeter and ammeter also, ammeter for amps. Which upgrade do you think will improve this charger the most? Drop a comment if you'd like to see me build a beta version with digital display and or USB charging. That'll be fine. So I'm just keep on making sure our network is stable. So let's power it up. Let's power this thing. You may think that we are bluffing, but these things work. Let's power it up. Let's power it up. Right now, I'm connecting this. You can see it's just a simple charger. I just built it to just make sure my battery charge after it charges automatically from the car. I don't know, it was maybe parasitic drain or what. I'll just sort it out because I'm a DIY person, so I fix most of these problems on myself. I fix most of these problems on myself. So I will let me connect this thing. Oh, sorry, I connected it before. So here, this transformer, I'll tell you where I got it. I'll tell you later. I'll tell you later where I took this transformer from, so that you can be able to salvage transformers like this. You don't have to spend money in this age we are. You don't have to spend money buying very expensive electronics, especially if you're in a hurry. So this cable goes to the common here. This is the common primary for a transformer. So let me just, it's just temporary. I'll improve it in our charger series videos coming very soon. And this one is the live. This is the live. You can see by this fuse. Yeah, because it's a live. But before you do this, most of the time you have to test the components very well using series lamp. Series lamp can help you avoid if there's a short in the components you are salvaging, especially these transformers, can go can give you a big blast, can even destroy you, or it can kill you. Yeah. So I'm connecting this to the main AC. Don't worry about this cover, it doesn't matter. I'm connecting it. Oh, sorry, wait. Before I connect it, so that I won't be able to be, I won't be electrocuted. And I want to show you all the voltage. Let's imagine only three components going to power this. Okay. So this doesn't have an issue with polarity. I'll show you how we test this. This is secondary side. Secondary side. I'll show you how you can test this to identify the secondary and the primary. If you want to support me, double tap on the screen. Double tap on the screen, or don't forget to subscribe. Subscribe for more DIYs take like this. So you go. Yeah. So now everything is okay now. There's no switch. It's just a test for now. There's no switch for this. I think you can see this comes to the battery. So let me move it to this, because this already has 13 plus volts. So here's what I'm going to do. I'll use this smart charger because this one looks old. There are no labels anymore. But this simple has an issue battery. Let's use this. I'll power it up. This is an auto. It detects auto AC and DC. So if I put it like this, I think you are able to see it. You're able to see the readings here. Sorry. So I'm going to show you from the mains, how many volts do we have AC. This is AC. Like this. You don't have to touch it. It's dangerous. You see, 219 AC volts. 200, 250, is it? Sorry, poor connection. It's poor connection. Do this. Two hundred and nineteen volts, 280 volts. Yeah, that's it. You can see this from the main. So this is the primary side of the transformer. Now our voltage now pass through this transformer and it steps down. It steps down, so we will be able to work with it to convert it to 12 volts DC. So let me show you here again. This is still AC. It's not a converter, this one. It's just a transformer. It steps down, it reduces 219 volts to 220 volts, which is the main common AC volts in the household, to 13 volts here. You see? You 13. Sorry, 10 volts, is it?
Yes.
Yeah, 10 volts. You have 10 volts. Our 10 volts then goes into this rectifier. The rectifier, I think I showed you at the back, was how did I connect it using, this is a temporary breadboard. Yeah, you can see there's nothing hidden here. So it comes here and be converted to DC. Then it passes through this filter capacitor to smooth out our DC to our output here. We get 13 volts to charge our batteries and start anything. You can start anything with this. You can work with this voltage for any project of DC. So let me show you. I charge this with the battery of mine. I charge my battery. This is the battery. I'm just connecting it so that you won't doubt this project. This is the battery. This battery is already full. Before charge, it was around the 4 volts. So here it is. It's full now. 12.63 volts. You can see. Let me connect it. Hopefully this charger works. This charger is the game changer. It's good for a DIY person, because most of the common chargers, they don't last. You can see after connection, what do we have? 12.64 averaged. Yeah. So I'm going to show you how you can test all these components. They have to be tested after salvaging. 1, 2, 3, but just 3 only. Just imagine if you test only 3 components and your charger is working. There's a lot of voltage here. And let me put something which uses DC. Which uses DC. I'll put this fan here. I'm going to put this fan, connect this fan, so that you know this is the real DC. And I'll show you also how to identify how did I get these wires as a primary. These wires as primary in such kind of a transformer with many wires like this.
9.
Yeah, with such many wires like this. So even you can make it, even without electrical knowledge. You can make a simple charger like this. It's just a simple linear charger like this. So let me connect this DC fan for you. Let me show you how this thing works. Just do me a favor, double tap the screen. Just double tap the screen if you want to see more DIYs projects like this. And I'm going to give you a series of DIY and even the upgrades. I'm going to upgrade this charger. I'm going to upgrade this charger on most of the live series which we are planning to bring to you. And apologies for bad network or for bad pictures. If there are bad pictures, then you can just tell me in the comments how is it. So I connected the positive to the red. Sorry, we are just trying to keep our network working. We had a big major problem with the network. So now this is the negative. I'm trying to run it. There it is. You can see. It's running, right? But it's a noisy fan. It's very noisy fan. There it is. So we still have a long way to go. Don't go yet. Just keep watching. There are a lot of things I'm going to show you, and how you can upgrade this charger to be like smart charger, a very expensive charger with salvaged components only. I'll test it also in my next video. In my next video, I'll test this on completely dead battery. So since yes, we have 12.8 volts here. We have 12.8 volts here, or 12.8 volts. I think you'll notice that there's nothing, just 1, 2, 3 combos. There's nothing. I've rigged, I've even tried to hide, you see, even battery, anything, yeah. Even these wires, they are not connected to anything. They are just transformer wires, and our AC main power is coming from that side. You don't have to keep touching these wires. This is supposed to wires, but this is just for simple. So let me tell you something. I have this other battery too. This battery is the 12 volt battery, but it's empty. This one is empty. I showed you before the full battery which I charged with this charger, and it took about 2 hours. Only 2 hours to fully charge this battery from 4 volts. Yeah, and this one also is about. Let me show you. Let me show you. You don't have to. Yes. Let me show you. It is, and you can see it. 5.267 volts. You can see 5.267 volts. And this charger outputs. First, let me talk about this. Why did I use this transformer instead of a smaller one, a portable one, especially for a car battery charger? A portable one like this. This is a portable transformer, I think you can see. But this transformer is for hybrids. It's for a hybrid charger or smart charger, which I salvaged this transformer from. But it won't produce amps like this, or even you can't put it in a charger circuit like this, linear charger. You can't. You must have only You must have only a. I'm sorry, apologies. Someone is playing music there. Okay. Someone is playing music, so we're afraid of copyright. We need to. We live in a highly populated area. So this charger is. I said you are not supposed to. You need fumble.
Yeah.
You need fumble.
Yeah.
I have my assistant here. I'm talking about this network issue. Where are you watching us from? Tell me. Do you have network issues like us here? And the network keep on interrupting us here and there. It keeps on interrupting us. Disconnecting, connecting, disconnecting, connecting. I think just a comment down if you can hear me clearly. Can you hear me on this mic? Can you clearly hear me? I just want to confirm if you can hear me, because I want to give you all information about this thing, so that you don't have to waste your money on buying big smart chargers, which are very expensive. I'll show you the one which I took this transformer from. So what I was saying is that don't use this small transformer in such kind of a charger. No, never. Because first, it doesn't have the frequency like this one. So it will need support of the support of our charger will need support of this high frequency transformer.
Introduction, new audience.
Okay. For those who are just joining us, I have here our charger here, this charger. We just built this charger, 12V battery charger, using only three components, main components. Transformer, our rectifier diode, the capacitor. Only three components to produce 12 volts battery. So you can double tap our on the screen or subscribe to support us, so that we can create more charger series videos like this. It's not easy, guys, to shoot a video, especially in my country. Sorry.
It's not working.
Okay. Can you hear me? Anyone? Okay. Just put a thumbs up if you can hear me. Thumbs up if you can hear me. Thumbs up if you can hear me clearly. To prove that our network issue is being resolved. We are in Zimbabwe. Where are you watching us from? So I was talking about this transformer. This transformer is secondary, is primary and secondary. And this transformer can output 10 amps to this. Then this rectifier diode is output of 6 amps maximum. So our normal battery car chargers, to charge normally, they need about 3.5 to 5 amps. For slow charging, you need 2 amps. Especially those ones we are trying to revive. But if it's the one we were using is down, you can just charge it on 3.5 to 5 amps. Yeah. So that's why we have these 6 amps diode here. Yeah. This will do the rest. So I wanted to show you the voltage on this battery. Double tap on the screen. Everybody. The voltage on this battery, it's 5.263 volts. All right. This battery is dead. But to show you that this charger is fast, as I told you before, the big battery I removed. To anyone who is just who's starting to watch us right now, who's joining us on this chat, we have another battery charged for about 2 hours only, and it was fully charged with this simple linear voltage charge. 12V battery charger. There it is. Now we are charging this from 5 volts. I want you to see that I can even wait for about only, I'll give it like minutes only, 60 seconds only. It will be charged for about 7-8 volts. It's not that strong to power anything yet, but it's a good voltage. What I'm trying to prove to you is that it can give you many amps, because I can test amperage with this kind of charger. You can see here, this charger says 600 milliamps maximum. 600 milliamps maximum. So this multimeter says 600 milliamps maximum. So if I try to measure amps, which is above 600 milliamps, of course this charger is above 600 milliamps, it will blow. So on my next series videos, I'll bring you the clamp meter, the clamp ammeter, or I'll bring you the clamp ammeter or another multimeter with 10 amps fuse. Yeah. Even you, when you are testing at home, don't use this 600 milliamps. I have this one, which is the right one, but it's old and it stopped working. It is like this 10 amps, which you have to connect. Let me demonstrate to you. You connect 2 amps this red lead, and you adjust to. Let me adjust for you. Show you to DC amps. Look for DC amps. There are no more labels, so I couldn't remember which is which. Where this was. It's a borrowed multimeter, so I don't have memory on what was this unless
someone is asking. Introduction. Someone is asking.
Okay. Oh, okay. If you are joining us right now, I'm showing you this linear charger, which are built using only 3 parts, only 3 components. 3 components. I used this transformer and this rectifier diode and capacitor, which is 35 volts. Yeah.
Yes, Andy.
Andy. I think you can understand this. That's how we built it. Have you ever tried to make anything? Have you ever tried to build any charger before, or any DIY charger? This even if you didn't build anything before, this is simple and practical. Here, this is our primer. Okay, let me show you again. Let me do this for Andy so that you can. This is our primer. I'm taking these are connected to 220 volts from the main supply, main adapter, into this transformer. This transformer, we took it from. Let me show you. We took it from a sine wave old inverter. He was dead already. Other parts were dead, but this transformer wasn't. So we tested it. I tested it and we find it useful. This is the sine wave transformer, the sine wave inverter. We salvaged this transformer from. So you can find these kind of transformers anywhere. Even microwaves. There are microwaves in this transformer, and even most of the inverters, old inverters, you can find this transformer, this kind of transformer. So I was saying also, don't use a smaller transformer because you need lots of components before to maintain to have high frequency so that it can produce the right voltage here, like this one. Don't use this one. Don't use this one. Even if you manage, you will need a bigger circuit. I will show you. Yes, if you are interested in making a smart charger, I will show you. Mike. Sorry. My audio, is it clear? Can you hear me clearly? If you can hear me, put thumbs up. And you guys, don't forget to like and subscribe so that we'll have more energy to make such kind of videos and salvage parts. I'm just looking for a board or smart charger. We have a lot of board here. A smart charger board. Can you show this? Yeah. This charger. This is a smart charger, you can see. So this charger is the one which prompted me to build this simple charger. So because someone reversed the polarity on this charger, so I couldn't manage to repair it because of some components I couldn't find them. Someone reversed the polarity. You can see that's where the output was DC negative, DC plus. Here you can see it. If you can see it clearly, the input was here, EC. Like Salvage did those things also. These claims came from this charger. So someone reversed the polarity. Just imagine how smart this charger can be, but it can't even manage to disconnect or stop power from bursting out these components. So I tried to repair this thing, but I couldn't manage to repair it because I was missing a lot of parts. A lot of parts were destroyed. I couldn't complete it. So I salvaged it. I put it on salvage. But this thing cannot beat this thing. This one. Yes, it's smart, but cannot beat these ideas. And I'll add more. So yeah, I was telling you that I'm showing you. I wanted to show you the amps, how we test amps going to the battery. But this charger is dead. But I just want to show you for learning purpose. This, not this charger, sorry, forgive me. This voltmeter is dead on testing amperage. It can't test amperage. It's dead. It's an old voltmeter. So here is how we test our amps. So how we test our amps. Even a single milliamps, I can't find any milliamp here. Why? Because this voltmeter is dead. This voltmeter is dead. So don't mind it. But I just wanted to show you how you test amperage. Where are you watching us from, guys? Where are you watching us from? Where are you watching us from? This voltmeter is the one we are using now. So after, I think we passed the minute. Let me show you if this battery gained something. Let's see. 11.71. This, I think that was like less than 5 minutes. So this charger is outputting about, in my estimates, when I was calculating this, when I was calculating the amps and voltage with this kind of transformer, it was around, by calculation, not by measurements, by calculation, it was around 3.5 amps. So this charger is too big. It's very big. Okay, I can see some numbers. Okay. Now I'll take your questions. Ask me anything about salvaging, electronics, or this charger too. I'll take your questions. So next time I'm going to build this charger with a more protection and adjustable output current. So if you are not subscribed yet, you don't want to miss upgraded version of this charger. And also don't forget to like our video. Yes, we are going to post more and more of this. Don't be left behind. Have you ever salvaged anything here? Did you ever salvage anything? Did you any questions? Any questions? I'm taking questions. Like, subscribe, like and subscribe. Just double tap the screen. Just double tap the screen. Any questions? Any questions? Do you want me to test this for you? Or do you want me to test this combo to show you how we can get from the primary to secondary? Do you want me to show you how we can find the primary on these cables? Anything, guys. Anything. So the final version is coming. This is not the final. This is not the final. The final version is coming. Final version of this charger is coming. So let me show you where we salvaged this thing. Yeah. And this that was the 400 volts. This is the charger. So here are the circuit boards which gave me these parts. This is circuit board. And this circuit board. There are a lot of circuit boards here. And tell me in the comments which item do you want me to build using this circuit position, or if anything you want me to test for you on the circuit, or even you can remove it and test it out of the circuit. I can remove it for you. Tell me, where are you watching us from? Where are you watching us from? And tell me anything good. If you want me to improve anything, if you want me to improve anything on this charger, what is it you want me to improve? Yes, I'm planning to improve on something, but I want your suggestion too. What else do you want me to improve? So let me show you. Let me show you something. What we have in. Okay, let me tell you something about the parts we are going to add. The parts we are going to add, and where are we going to add them? First, we have here our 3 amps fuse here. This is our 2 amps fuse coming from through the line from the main, right? So what are we going to add? We are going to change this kind of wires. These are pin. Since I told you this was for sample only, so these are pin wires. Now we are going to change these wires, and even the socket top plug, we're going to change it, and the fuse will come on board. And this board, do you want me to keep on working on this kind of board, or you need a breadboard? Do you want me to use a breadboard for DIY purpose? For DIY purposes, I think that was cool. That was cool. What do you think? What do you think about this board? Tasty. Tasty. So now I'm going to disconnect this. I'm going to test this transformer for you. I'm going to show you how do you salvage parts. Let me show you how do you salvage parts. So I'm going to disconnect this transformer from the power. Salvage parts. Don't do this when power is connected. You see me, I just disconnected the power so that I don't get short. Let's remove this, all of these things. So if you find a transformer like this, I want to show you how do you find primary and how do you find primary in the secondary for these transformers. There's such kind of transformers. This is gold in electronics. This is gold, this transformer. It can help you do a lot of projects with it. From adjustable power chargers to even other inverters. If you want to build another inverter, even a simple one with this few seconds. That's why I want you to tell me in the comments which circuits do you want me to build again on the next video using salvaged parts. Because I have a lot of circuit boards here. I have a lot of circuit boards. There are a lot of circuit boards. Waiting to be salvaged. So on this part, I said I'm going to show you how we can identify the primary and the secondary for transformer. Let me show you. Is this visible? Yeah. Let me show you. Power up the voltmeter and adjust it to ohms. I would just suggest around 200 ohms if your voltmeter is adjustable, but this one does automatically. So first, you have to find where a socket like this with many cables like this, or with the different colors like this, not this one. If you have salvaged a transformer, or if you are in any kind of transformer, you have moved. So first identify the common. The common is this, the black one. The black one is the common. So what you are looking for here is a combination of any two against the common. One of these against the common with highest resistance. Most probably around 4 to 10. Around 4 to 10, that's where it is. So what you do is this: you take your black here to the common and our red to this first. That was so it ran out of batteries. This much doesn't have batteries anymore. So I'm going to use the adjustable one. And you will adjust it. Yeah, adjust it. So I can show you the light here. Just the light. So it's making noise. It's making noise because it's run out of batteries. It doesn't have batteries anymore. So we just put it aside. So let's identify the common. Let's identify the primary. Like this. I think our temperature range is low. Just to Oh, sorry, I forgot to remove from the ends spot. Let's put it here. Where are you watching us from? Where are you watching us from? Tell me in the comments where you're watching us from, and anything you'd want help for. This is 4.5 ohms, 4.4 ohms. And let's see another cable. This is 3.5. This is 3.2. 4.1. 3.9. So this one, that's how I identify. That's how I come up with this as a primer, which worked. So that's how I come up with this. It's hot. It's hot here. Very hot. It's very, very hot. So let me power it again. Can you see me clearly? Pictures. So give us a thumbs up. Give us a thumbs up. Give us a thumbs up. Okay. Give us a thumbs up. Just double tap the screen. Double tap the screen. Double tap the screen. Subscribe if you are new. Subscribe if you are new. Because we have series with lots and lots of chargers and circuit boards to Salvaged. So if you are just joining us, this 12V battery charger was built using only 3 Salvaged components on a plastic board. This is the plastic, just from a plastic container used of oil, not a breadboard. Just imagine, and it works. So anyone can make this thing. Anyone. If you didn't do any electronics before, you can make this. Just see if you have any question about it and how you can do it, just ask me in the comments. I'll walk you through. Only 3 parts. And if you don't have access to this, let me tell you something. If you don't have access to a rectifier diode like this, and you plan to use normal diodes, this is mostly for beginners. Normal diodes like this one, like this here. If you want to use normal diodes like this, don't use IN4007. Use IN5408. Those are the right diodes for this thing. Those are the right diodes, and you want to build your bridge rectifier there. So that's how it works. You won't fail. I'll always be with you. And I'll walk you through. Even in the comments after this live, I will help you to walk through anything, even the testings. So here I showed you how you can identify the primer, right? So I'm going to show you how you can identify the secondary, even how I come up with this. Where is the secondary? So I'll show you, but let me explain more about this thing. Since here, so how am I going to upgrade this? It's like here I'll put a fuse to avoid the backfeed, to avoid even any short, because protection is good. The protection is good, and the voltmeter and the ammeter I'll also do that. But I want your suggestion if you want me to continue on plastic board, or I have to buy a breadboard so that I can complete this project there. What do you want me to do? Tell me what you want me to do. Anyone comment down below. Comment down below. I said we are going to use a 10K, 20K potentiometer, 10K potentiometer to adjust, to have adjustable voltage here, and the 5 MC DC fuse, and a diode to prevent backfeed.
5%.
Okay. We are having challenges again with power. A lot of forgive us guys. Next time we will have better things. Some things are just beyond our control, like network. It's controlled by the state. You can't even by parastatals, by parastatals. So you can't decide when is it going to be fast or not. Yeah. So thank you for watching me build a real charger with only components. Like, comment, and share this video. Replay it from the beginning if you missed anything. Before you go, hit like so this stream reaches more DIY lovers, and share. This stream stays online. Rewatch anytime and share it with your friends. Thank you for watching us. Bye bye.